Fiber optics, principal is the total internal reflection. Fundamental parameter is the refractive index, n. The n is the velocity of light in free space divided by the velocity of light in that particular medium. Snell's law for non-magnetic medium is the eta 1 or n1 sin phi 1 equals to n2 sin phi 2. Now the critical angle phi c, where sin phi c equals to n2 by n1, that is the under root epsilon r2 by epsilon r1. Inside the fiber we have the core, cladding and jacket. The core has the refractive index n1 and the cladding has a refractive index n2, and this n1 is always greater than n2 in order to have the total internal reflection. Now you have the launching angle or the incident angle phi, and in this angle must be greater than phi c, that is the critical angle, in order to have the total internal reflection. And here it is core and here it is cladding. Now for step index fiber and for graded index fiber, both we have fiber we have the two type of light propagation. One is called the meridional propagation, another is called the skew propagation. So this is the meridional propagation. In the step index fiber, you are launching the light through this fiber axis, this point, and this light always cross the fiber axis. And this is the skew propagation, where you launching the light wave in some arbitrary direction, and which must satisfy the total internal reflection condition. And the cross-sectional view of this skew propagation is this one, and for meridional propagation the cross-sectional view is this one. Similarly, for your graded index fiber, the skew propagation follows the helical path, and for meridional rays, the propagation will like this curvature path, this curved path, right? In case of your graded index fiber. Next is the angle of acceptance angle, or the maximum acceptance angle. It is denoted by theta, or you can alpha, right? And this is not the acceptance angle, and it is depends upon the eta 1 and eta 2. And note that the angle of incidence must be less than or equals to the acceptance angle. This angle of incidence of light, that must be less than or equals to the acceptance angle. Then only you have the total internal reflection inside the fiber. Next, numerical aperture. If you have the acceptance angle alpha, in that case your numerical aperture is sin alpha, which is under root eta 1 square minus eta 2 square. Eta 1 is the for core, and eta 2 is for the cladding, the corresponding refractive index. And the full acceptance angle is known as the 2 alpha, and your the acceptance cone, this cone made by this based on your acceptance angle, this cone is known as the acceptance cone. There is another parameter called V number. The V number, if the V number is less than 2.405, then the fiber has a mono mode. If the V number is greater than 2.405, then the fiber has a multi mode. So now if you know the V number, then you can easily calculate the number of mode in the fiber. That is, for step graded, this is V square by 2, and for the for step index, this is V square by 2, and for step graded in fiber, you have the V square by 4. And this is the formula for V number. V number is pi into d by lambda into numerical aperture. So here is a typical example for based on the V number you can calculate. So now the single mode fiber and the multi mode fiber. For single mode fiber, the core is small, less dispersion, carry a signal ray of light usually generated from laser, employ for long distance application. On the other hand, for multi-mode propagation, the the size of the core is large than the single mode cable, allow greater dispersion, and therefore the loss in the signal dispersion is more. Used for short distance application, but shorter than usually up to 2 kilometer, and the LED is used as a source. Now you have the step index fiber and the graded index fiber. For step index fiber, your refractive index suddenly changed, or or abruptly changed at the interface, but for graded index fiber it is continuously changed parabolically or the linearly changed. And here for the input pulse you have corresponding output pulse in both step index and the graded index fiber. The difference between the step index fiber and the graded index fiber: note that in step index fiber you have the more attenuation, but in graded index fiber you have less attenuation. In graded index fiber you have basically skewed ray propagation, and we basically use the skewed ray propagation, and for step index fiber we basically use the meridional rays propagation. So you have the helical light goes in the helical manner, and in that case your in case of step index light goes in a zigzag manner. Now another parameter called the code cladding index difference delta, which is delta equals to n1 square minus by n2 square divided by 2 n1 square, and which is nearly equals to n1 minus n2 divided by n1, as n1 is nearly equals to n2, and the numerical aperture is equals to n1 into under root 2 delta.